Okay. So I wanted to ask if any one of you ever used the useReducer, but there was yes, it was Paul. How many of you? Okay, how many of you use tools like Redux and this kind of stuff to manage state? Okay, so all the people who don't use Redux use the useReducer, I guess. Or maybe a lot of you stayed, as they just said.
Some problem with the connection. Connessione.
Oh. Okay, while we wait, I'll introduce myself and Mattia. We work at MV Labs, which is sponsoring this event. And we work mainly in industrial environment, where the workstations are not the typical office or home setup. Working conditions are very filled with noises, and people use big tablets with gloves, so we tend to think a lot about their experience, and performance in their in that environment is not always the best. So we tend to it's a little different than the usual development. And okay, I'm I'm out of ideas.
Should I help? I'm happy to come help fill up some space.
Thank you.
Is it working? You
Yes,
have?
yes.
Good.
Right,
Okay.
Now it's working.
Good.
Okay.
I was gonna tell a joke. I don't have to now. It's good.
Okay. Let's see if it is
Okay.
working too. Okay.
Yes.
Yeah. Now we can start.
Can you listen to me?
Yeah.
Okay.
Okay. Perfect. So now we can skip over the first part.
Yeah.
And okay, Mattia, our architecture.
Okay. And our architecture is based on microservices. And be sure that we will be reminded of this throughout the talk.
Okay, at home, I'm a two boy kids mom, the most beautiful in the world, if you didn't notice. And I enjoy a lot of boy kids stuff too, like animated movies, manga, and sports.
As for me, I like watching Formula 1. I'm a fan of Ferrari, the best moment. My hobbies are working out and coding in Dart, Flutter, and React.
Oh, okay. Look, Mattia, we got mail. It's a new project request. Check it out.
Oh, hope you are doing well. I'm thrilled to kick off our project, how to furnish your nest. To get things rolling smoothly,
Oh,
here's a quick
look,
overview.
Mattia, he says that the project specs are attached. Just check them out.
Oh, it's a web configurator of a dragon nest. This page is highly interactive. I'm concerned that we'll have a lot on our plate in terms of managing complex states.
And also on the other side, on the other parts of the application, I don't think that useState will be enough this time.
Yes, me too. I don't think useState is the right choice for our project. It's too limited, when the state is more complex than a single value. What can we do?
Let's Google for some other solutions. Here they say that StateX is the best library for state management. Let's check what it does. It says that it's based on the concept of a single source of truth.
Yeah, meaning that there's a JavaScript value containing the entire state of the application.
And then it says that it follows the Flux architecture.
Yes, the Flux. We start with the view. That basically is what we see on the screen.
The view is provided data by the store, which basically is an object containing all the application state tree. But what does the view do when a user interactions come by?
Through a dispatcher, the view can send actions to the store. Based on the action trigger, the dispatcher updates the store, closing the ring.
Okay, one of the main pillars of the Flux architecture is the concept of a pure function.
A pure function is a function that, given the same input, it always produces the same result. It's predictable.
Oh, statex is so cool.
Let's go on and see how our application will look like after we integrate statex.
Let's check out our application again. It is composed by 3 main pages.
So from the specification, more or less, this will be our component tree. A root divided into branches.
So going down the tree, we can see that the first page is a configurator page, which is divided mainly in 2 sections: the furniture selection and a preview of our nest when we put the furniture inside.
Then we have a projects page, where the main component is a list of projects made of a preview and some metadata of the project.
The last page is the project detail, where we have also 2 sections: the list of furniture we put inside our nest, and again, the preview of the nest.
Let's start with the state of the preview component, saving all its values: rotation, position, scale, the piece of furniture, and so on.
As a state tax suggests, we're going to put all of these values inside an object defined in the root of our application. And then we give it some actions to update it.
This way, every preview done my component tree can access it and trigger it. And we made it.
Oh.
That was quick.
Okay, but wait. Does it mean that every preview around our application now just shares the same state? I don't think this is what the designer wanted us to do.
Oh, you're right. We can just replicate our state, one for every preview.
Okay, but we will have to do it for every piece of state of our application. And this is just the first release. As time goes by, more features will be added, and the state will grow even more. Our state, in the end, will be huge and always present all around our application. I think this can lead to performance problems and a lot of useless render.
Oh, come on. Performance issues are not a great deal in 2023. We have a single source of truth, and that's what matters. Let's go on and implement everything this way.
Okay, we're almost done. What's missing on your side?
Almost ready. I just need to ultimate this refactor here. Okay, done. Wait, what? List preview? This is not a component I was working on.
Did maybe your refactor involve rotation factor of the preview?
Yes, why?
I may have changed your value while I was working on my list preview.
Why did you do something like that?
It was late and I was like in a hurry, and the designer asked me to preserve the state when I was navigating from the list to the planner view. And so I just updated your value because I could too. Okay, I could. I'm sorry.
With statex, all seems so clean. How is it possible that we interfere with each other?
The architecture was not so clean after all.
Yeah, the single source of truth was a trap.
We can see this beautiful flow. When in practice, we have this one, because every component can change the value of the state of all the other components with no limitation.
This is a violation of the Demeter law. That states that each component should have only limited knowledge about other component states.
This one is worse than a performance problem. We need to ensure that our teams can work in isolation without the risk of messing with the other components of our application. We need to do something.
We can try to move the state up or down in the component tree, accordingly to where it's needed. In our case, the user can stay on top, and that's obvious. Planner can be moved in the planner component.
But what about our preview state of the preview component? Do we want it to be shared between the furniture selection and the preview itself? Or do we want it to be locked inside the preview?
This is not so easy. I will go with the preview component. It's something of its domain in the end.
Okay, you're right, but what if the designer then come and ask us to share the rotation of the furniture objects and the rotation of the nest? What do we do then?
Then we will need to refactor some code to bring it up to the planner component, all of it, or just one part of it.
Oh man, we will need to go through this decision for all the state of our application.
Yes, will not be so easy. But in the end, the state will be updated only by the elements we know that can update it.
Oh, you're right, and I prefer to make this decision now between us when we have the time, then leave the choice to our developer that maybe when the times come, he has no time to decide if it is the correct choice to mess with the other state. Okay, but what about the designer request of before? How do I update the planner from my list component now?
We can choose a more declarative way, separated from the state. For example, we can use the view URI. So in our case, we can pass preview arguments as query parameters. Here we set the zoom to 90. Then the component will intercept this message and signal a state change. This will validate the data, and if correct, a new state will be generated.
Oh, I get it. It will be like sending messages from one state to another.
Yes, this way we maintain the interfaces between component communication, separated from the logic of state management. We let each component choose how to handle its own and children state when an external request arrives.
Oh, I feel like I have already studied this thing before, but I can't remember where. Oh well, it seems that we resolved all our doubts. But StateX is not built for this kind of stuff. We are back to square one. StateX is cool, it is widely used, it is maintained, it has a lot of utilities, but in our case, the violation of the Demeter law, it's an issue.
Wait a moment. I was just hanging around the other day, and I came across something useful. The useReducer hook.
Oh, what's a useReducer?
The useReducer is a React hook. It returns a read-only state used by the view, and a function used to emit new actions. As a parameter, it takes a pure function, where we build a new state, starting from the previous one, and the action. A reducer example can be the following, where we instantiate a useReducer with a preview reducer function, in which we intercept the change rotation action and change the state accordingly. So in the component onClick event, we can dispatch the action to edit the state.
It seems very similar to StateX. It is also uses the Flux architecture, and they have a lot of pattern in common. But it seems to me that it is less powerful and less extended. Wait, does it mean we have to write some custom code?
Yeah, but they say this easy. We first create a custom hook where we return a useReducer, but with the reducer function wrapped in an answer. This is the place where to put all our powerful extensions.
Okay, but what do we write inside our function? Let's suppose we want to keep an history of states for our user and let her undo every action she did. How do you do it?
First thing, we need to intercept only what is interesting for our enhancer. In this case, we intercept the undo action and write our enhancement inside of it. In practice, we first check if there is a previous state available. If not, we do nothing and return back the state as it was. If you can undo instead, we pick the last state from history and return it as a new state.
Okay, now we need to handle the case where the action was not for our enhancement. In our case, when the action type was not undo.
If the action didn't match the one in an answer, we skip over and just replicate the regular reducer does.
Oh, I get it. This way is like if we are writing the reducer function inside our answer, but we know actual knowledge of what the reducer does.
Exactly. But we do something else now. Before returning, we store the new state as the first element of our history and return modified state. We can also define some utilities to return as an enhanced capability of the reducer. In this case, I'm returning an object that tells me if undo is possible in this particular case. And that's it. We successfully built our first enhancement to the basic reducer, and it just takes us 5 minutes.
Wow, it's incredible. Okay, let's wrap it up and ship her up.
Oh no, a message from the QA team.
Code is broken. He says that the reducer function is called twice. What does it mean?
It has happened to me before in React 16. Now I'll explain. Let's start from a random component tree. We take two components, where one is parent of the other. Our enhancer is used in the child component. And its parent has some stateful action, like a simple counter. When a callback is fired with the set count inside the parent component, a re-render of the component is executed, and B component is recreated.
In JavaScript, functions declared with the function keyword and also anonymous functions are treated like objects, so they are always recreated with different pointers. Therefore, also our enhancer is always different for our re-rendering algorithm. Even if the enhancer body function is not changed, when React compares it with the previous render, it sees it as a different one. And this, in some particular cases, may lead to bugs. What can we do to fix it?
Using the React use callback, we can decide when the function can be recreated. Does not mean invoked.
Wait. What's a use callback?
Use callback is just another React cool hook. The first parameter is the function we want to persist. And the second is the dependency list of values for which we want to react and render the function. In our case, we choose to re-render it only on component mount to prevent strange behavior and also prevent non-pure function invoking. We could use this bug as a pretext to analyze how hooks and fibers are made in React and how they work. But this can take another entire talk, so if you're interested in this topic, check out the article on the link.
Shall we go back to QA now?
No way, we need to run our test first.
Oh, let's see. Oh, yes, we made it.
We made it.
Okay, we shipped, and all seems okay. Hey?
It's John. He's asking for more features.
Whoa, more features. A show off your style. AR magic. Oh, AR. Well, that's great. New feature. Let's now see our reducer even more.
Wait a minute. We understand how features can be easily added. So we might be tempted to add other features inside the same enhancer. And more. And more. But this is the hook that every reducer around our application will use. Are we sure we want to upgrade all reducers equally? I think some reducer may be less powerful or simply different.
You're right. And I can spot another problem here. With this approach, we are violating the single responsibility principle that says that a module should be responsible of only one actor. In our case, our enhancer function should do only a single task. But every situation may ask for more than one task to be executed. So we need a way to pick just some of the enhancement and leave the others at all.
I can think we can do something like this. Starting from a reducer, we wrap it with only the enhancement it needs. When we define other reducer around the application, we can wrap them with all and only the enhancer they need.
Oh,
For every enhancement, we can also pass the parameters it needs through an object of options.
okay. You're applying the decorator pattern, attaching new behaviors to objects by wrapping one object inside the other.
Exactly. Moving on UML, we have the useReducer that call a reducer. The reducer can be either the actual reducer function or a decoration, which in turn can be nested with another decoration or the concrete reducer.
Okay, wait, this was fast. Let's stop for a second and think what we did up until now. First, we met state tags. We see how the Flux architecture flow works, and we understood how a single source of truth approach to state management works. Then we stumble upon some status limitations. As more features are added, the more the state will grow, and the more the performance will decline. And even worse, every component can mess with the state of the other components, even the one they should not. That's why we decided to go for an approach of a more distributed state. But be careful. Choosing the right level of abstraction for our state is not so easy. This is where we met our useReducer. We discovered that he is very similar to state tags. And we saw how easy it can be to enhance it. But not everything runs smoothly. And we discovered an annoying re-render bug, which gave us the opportunity to explore another useful React hook, the use callback. Okay. Then we needed more enhancements. And we realized that not all the states around our application needs the same enhancement. So we just split our enhancement in many little enhancements just to cherry pick them using the decorator pattern. And that's it. This was a lot of stuff to follow in 20 minutes. What do you think? Well, and we're not done yet. So, are you ready? Now we're going for a deep dive into something not everyone likes. Typing stuff. And I must tell you, if you're not a type kind of guy, this one would not be so easy to follow.
Oh, it seems to me that there is nothing to ensure that by defining the action of reducer, this will be managed inside of it. And for every new reducer, we are writing a new switch case. I think we can avoid it. But to do it, we need to refactor some code.
What? But it's JavaScript code. We can't just go back and pretend we remember what we did 2 months ago.
Yeah, I can understand you. An idea is to convert JavaScript code in TypeScript. This will lead to a code base easier to maintain, with just the effort to write some more code for the interfaces. We can move from a reducer function to an object reducer, where each key is the action type and value is the callback we want to fire.
Okay, so let's go for a concrete example. Let's suppose we have this object reducer, which handles just 2 actions, increment and decrement. These 2 actions as a value, as the callback function we want to fire when this action is triggered. This reducer will handle a particular state object that must have the count property of type number. So we define the counter state as an object with a count property. Same goes for the kind of actions it will handle. In our case, the counter action will be a union of types with just one property, name type, increment, and decrement.
We can also define other property of the action that can be used by the reducer function when handling that particular action.
Once our reducer is a typed object, if we omit something on the reducer, TypeScript will highlight the error, in this case, which is telling us that we're not handling the increment action.
The ability to infer the correct type in state and action provide additional help. For example, here we know that the type of the action is necessary increment. This way, if we define some action with particular properties, we will know they are present because TypeScript knows the exact type of the action.
But how do we define the type of our enhanced reducer itself?
We have to define an object reducer. Here it's important to use generics to make it extendable as we want. The structure of our final reducer is strongly dependent on the possible actions. We see here the counter actions as a concrete example. The reducer object should have an entry for every action possible.
Okay, in practice, we need to map on the key side of our object all the value of the type property of our actions. But what do we put on the value side of the object?
We need to put there the callback, which has to be called for the specific action.
Okay, so on the value side, we have a function which takes as input a state and the set of actions. And a state and an action. And as output, it gives the new state.
Yes, the action is the union we put in the generics, and we saw before. But to assure the right inferred by TypeScript, we sign the action property like this. For the state, we need to put it in generics, and will be whatever the reducer needs, like our counterexample. And that's it.
Wow, this was a lot of Notion in just 5 lines of code. Just to know, how many of you use generics in TypeScript?
Oh,
Not all.
great.
No, not everyone. Okay, and how many of you do know the infer keyword in TypeScript? See? Now we need interfaces for action and dispatch. The good news is that we can use the definition of the reducer we made before and just infer their types.
The next step is the enhancement type. We extend the reducer state with the canUndo property. We add the undo action and create a new dispatch that accepts the previous action plus the undoable actions. Adding all together, we have this. We start with the reducer of type enhanced reducer, and we return an enhanced version, adding the undoable reducer state and dispatch. Taking the counter reducer example, the result will be the following.
Okay, but after all this refactor, does it still work?
The reducer now must be written as object, but the test can be the same as before, and of course, we ran them and we made it.
Ooh, so wrapping up the useReducer. We can put it wherever we want, and we are not bound to a single source of truth approach. We saw that it can be easily enhanced, and performance will rise. On the other hand, there will be a little more code to write, and the state of a component must be clearly identified, and it will not be easy at all. But once everything is well defined, managing and extending it will be very simple. And of course, being a distributed source of truth, it's more difficult to hydrate state from server into client. So we see how simple it is to enhance reducer and how to decorate only the state that needs it. We made some example. Now it's your turn to create your own reducers.
So, Statax is a made-up name. I used to grab libraries that follow the idea of having a single source of truth for managing an application state. Some of the concepts we use, like the ability to undo actions, are inspired by some Redux tools. However, we demonstrate that similar concepts can be implemented with a little effort, but using a different design pattern. The main focus was to demonstrate an approach more focused on distributing the application state through different parts of the application. In practical terms, it means that when we work on various projects with different teams in our company, we try to make the most of what React offers before considering other libraries. We saw the useReducer for the state management and the power of use callback to be more performant. For instance, we use an answer reducer when creating forms, applying configuration, creating zero dependency code base shared in different projects without binding projects to libraries and not requiring more documentation than the React ones. In a nutshell, the talk aims to stress the importance of the single responsibility principle, where each part of an application should have a clear and distinct purpose. It also highlights that using Redux or similar libraries is essential, but not for everything, as overusing them can harm the overall design of the application. For instance, just because Redux has a library for handling data persistence doesn't mean we should use it for unrelated information.
The core message here is to promote a more flexible approach to state management and ensure that different states in our applications are appropriately abstracted and managed. And it's important to remember that
a single source of truth can be a trap.
Thank you.
That was a great presentation.
I hope we not run too much because we were very excited.
No, it was great. Wasn't it good? Wasn't it good? Yeah. Great. We have a few minutes for questions. Is that okay? You feel like answering some questions?
Yeah, Mattia can answer all the questions you want.
Great. If you have any questions, you show me your hand, and then we can run and give you a microphone. If you don't have any questions, that's also fine.
It were all so clear.
Yeah. There you go. All right, here.
Hi. I was wondering, when you're using this approach, why wouldn't you consider the use context as well? I mean, then you would actually mean to create the Redux functions for each context and have so many actual reducers for each single context, meaning user context, in this case, project context, something like that.
Yes.
A preview context. Or whatever.
The idea is to split the state management inside where only where is needed. So not creating just one state and put it on the root of the application, or compose more state and put all on the root of the application, but distributing the state only where is needed. So the other components can view, dispatch, or interfere with the other state. And we suggest a more declarative way to communicate between the state, like using the URI.
I don't know if we understood the...
So,
okay.
More questions? No? Yes? No? Okay. Well, going once, going twice. Great. Give it up one more time for your speakers, everybody. Brilliant.